Alright, welcome back. This is Unit 2, Day 8, so it's on page 41 of your note packet. The top has a warm-up about showing that it is a 0, so you want to make sure the remainder is 0, nothing else, when you do synthetic division. And then it says find the remaining 0, so that means you want to do the p over q and find all the possible ones. So if you want to do p over q, it would be 12 over 1. So we would have plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, and plus or minus 4. On this one I'm not going through upper bounds and lower bounds, but if you want to try doing one of those, that's fine. But initially I just want you to just show -1 works. So you can do synthetic division, you can do a couple other ways if you want to plug it in and show me the remainder is 0, that all is essentially the same thing. Potentially synthetic division is a little bit more direct because it will get you right to the 0 and will actually give you a new function to work with. So this is x to the 4th, so I'm now down to x to the 3rd. So we have x to the 3rd minus 3x squared minus 4x plus 12. Alright, so I'd have x by grouping. Remember, these are nicely set up for you, so sometimes, occasionally, they may not be, so just to give you a little bit ones to try to work a little bit more, but generally speaking, these are worked out pretty nice for you. Alright, so by grouping, I have that, so pull your parentheses in. I have x plus 3, sorry, up here. No, just kidding, x minus 3, and x squared minus 4. So I have x minus 3 is equal to 0, so x is equal to 3. I have my x equals -1, and that works. And I have the other one, which is equal to 4. Add the 4 over, so I get 4 square root, so I get x equals positive or -2. So I have -1, positive 3, positive 2, -2. Those are for your 4 zeros. Alright, so we're going to keep writing these as polynomials as product of linear factors, which you guys have already done actually. You took the graphs on the quiz and you took the zeros and wrote them as linear factors. Alright, so use a graphing calculator to help you write f to the 5th plus x to the 5th plus 3 to the x to the 3rd plus 2x squared minus 12x plus 8 is a product of linear factors. Alright, so p over q, so this finds the real zeros. So p over q is 8 over 1, so I have plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4. So these are the possible real zeros that you can have. So when I look at the signs for Descartes' rule of signs, no, I have one change there and a second change there. So the positive zeros are 2 or 0. And the negative ones, let's see, I'd have negative x to the 5th minus x to the 3rd. That one doesn't change, x squared. 12x will, and 8 will stay the same. So let's see here, we have one sign change there. So that means you're going to have one negative number is a real 0. So kind of keep an eye on this because this is a degree 5, so it should have 5 total zeros. Now that's going to include real and imaginary. And you can see the graph here. This is a 5th degree, so it's an odd power. We got up on the right and down on the left because a is positive, so it goes that direction. Alright, so we have a negative here. So looking at the graph, -2 should be a 0. Positive 1 should also be a 0, and because it bounces, this should be repeated. And because it's a U shape, it should be repeated 2 times. So to do some synthetic division, so because I need all my numbers to get them as powers, product of linear factors, so I have x equals -2, so that's what I'm trying to try in my synthetic division first. So Synthetic division should end in a 0. Nice line, hey? So I have 1, 0, don't forget your placeholder, 2, negative 12, and 8. 2, 4, 5, negative 10. Negative 8, 16, 4, negative 8, 0. Yay, it works. Okay, I also, so there's my, I have one negative answer, which is a 0, so there's my 1. I have 2 positive answers. Well, I know I have repeated 0 here at 1, so that's going to be my 2. So I'm gonna do x equals 1. 1, negative 1, negative 1, 4. Let's see, 4, negative 4, negative 4, 0. Yay. Alright, because it's repeated, 1 should work again. So I started as x to the 4th, no, sorry, x to the 5th. 1 level down is x to the 4th, this is x to the 3rd. So I'm making my exponent smaller each time, which is actually much better to work with these numbers. Alright, so I do 1 again. Don't worry about the x's, you can ignore those. I have 1, 1, 0, 0, 4, 4, 0. Okay, so you can see even when it's repeated like this, the bounce, or if it's cubic and it goes kind of flat, the repeated 1 should end up in 0 if you do it 2 times, or no matter how many times it does it. Each time you do it, it should end up in 0. Now, I don't want to do it a 3rd time. It's not going to end in a 0 then, because it's only repeated 2 times, so I don't want to keep doing it over and over. So, back to what I started with. X to the 5th, x to the 4th, x to the 3rd, x squared. So, to write this, to figure out linear factors, I need just plain x. So I have x squared plus 0x plus 4, 0. So I can get rid of, that can go away because I don't have any x's. So I need to solve. Subtract 4 to the other side. X squared equals negative 4 square root. Square root. X is going to be plus or minus 2 and I. Okay, so there are my 5 answers. Negative 2, positive 1, positive 1, positive 2i, and negative 2i. So to get them as linear factors, you've done this before. Whoa, sorry about that. So you get x equals negative 2, so that means it's x plus 2. So move it back over to the other side with the x. I have x equals 1, so that means I have x minus 1. And since I have that 2 times, I'm just going to put a squared on it. Or you can write them separately if you like. Now I have x equals 2i. So I move the positive 2i over, so I have x minus 2i. And same thing for the negative. I have x equals negative 2i. So I have x plus 2i. So I should have degree 5 total, imaginary and real answers. So I have 1, because I have 2, I have 1, 2, 3, 4, and 5 factors there. Okay, so this is what's looking for, linear factors there. So it's all these parentheses in one. Alright, so on page 42, alright, so this is one of these pattern ones, x to the 4th minus 16. As a product of linear factors means I want just x, so I want x plus something or x minus something. Linear means it doesn't have an exponent of 2 or 3 or 4, so I need to factor this first, so I do x squared minus 4 and x squared plus 4. So that's one of those ones where you have special numbers, so it's just like x squared minus 9. Because these are perfect squares, it would be x minus 3 and x plus 3. X to the 4th and 16 work the same way. They are perfect squares. X squared minus 2, just kidding, x squared minus 4 and x squared plus 4. It works the same way as if you had a squared one. Now, these work the same way. So when you have the minus sign, it's x minus 2 and x plus 2. Now, if you forget how this works, when you get down to a squared, you can always set it equal to 0 and solve that way. So add the 4 over, so you get x squared equals 4, square root and square root, so you get x equals 2 plus or minus 2. And then work the factors backwards. So you'd have x equals 2, and then work backwards to x minus 2. Or x equals negative 2, and work backwards to x plus 2. Okay, same thing works for the x squared plus 4. When you have a plus sign in between two perfect squares, these are imaginary factors. Okay, because if I solved x squared plus 4 is 0, I would subtract the 4 over, and you would square root, so x is plus or minus 2 and I. So that's why we did all these imaginary numbers first. So x equals plus 2i, so you would want to move the 2i back over, so you have x minus 2i and x plus 2i. So we talked about conjugates before. Conjugate always occur in pairs, so there's always 2 of them. Because the only time we get imaginary is when we square root, which means you have to have the plus and minus sign. So if you have a plus bi, that automatically means you have a minus bi. So what this is saying is something like this. Look at example 3. When you have zeros of 1, negative 1, 3i. Anytime you see the I or you see a root, this automatically means the opposite of that is there. So it means x equals 3i, and it automatically also means x equals negative 3i. Conjugates, or i's, and the roots always occur in pairs because of the square rooting feature of getting plus or minus. Okay, so it says write a polynomial that, so we are actually going in the reverse of what we did here. We factored it out, and if we multiplied, we would get back this. Okay, so I have 0 is x equals 1. My 0 is x equals negative 1, x equals 3i, and x equals negative 3i. So I have 4, 0, so I should have x to the 4th. So as my factors, I have x minus 1, I have x plus 1, x minus 3i, x plus 3i. To write a polynomial, start foiling it out. X squared minus x, so 2 at a time, minus x plus x minus 1. X squared plus 3xi minus 3xi minus 9i squared. So you gotta keep doing these I squared things. X's cancel out, you have x squared minus 1, and then this one, 3ix, cancel out, so you have x squared minus 9 times negative 1, so it's x squared plus 9. And then finish by foiling these out. X to the 4th minus 9x squared, no, sorry, plus 9x squared minus x squared minus 9. X to the 4th plus 8x squared minus 9. Alright, so something like example 4, where you have a 0 is 3, so I leave that alone, so it's just positive 3. Anytime you see I, you have x equals 1 minus 2i, and you have the conjugate of that x equals 1, change the sign in the middle, plus 2i. So moving back over for factors, x minus 3, and x minus 1, whoopsie, x minus 1 plus 2i, and then x minus 1 minus 2i. So foil these out, and I will have the answers shown out in detail on Classroom. I will post another thing. Also, so I will put this on Classroom. Try this first and then look on Classroom for the answer.